I invited him. Yeah, now we're on broadcasting.
Sweet. We're doing lesson. What lesson are we on?
11.
11?
Yeah.
Okay, sweet. Just making sure.
I'm gonna see if I can post.
Oh, so they can watch it?
Well, I'm just posting the actual
URL?
link. Yeah, the URL. So in case the invite doesn't work, they both have it. Do you guys have any questions about the information?
Nope.
Mhm.
Cool.
Are we just waiting right now?
Yeah.
Yeah. The quiz doesn't look super hard, guys.
I'm looking at it right now. It doesn't look
Yeah.
bad.
It doesn't look super hard.
Let me see if I can invite them again.
Did you get the TA's phone number in case we were having problems?
No, I just have them on my email.
Do they? Do you think it's listed on our syllabus or something, or on our thing?
But TA's numbers?
Yeah, or just how to contact them?
I'm not for sure.
I'm looking at it right now. I have our teacher's number.
Excuse me.
Hey guys,
Hey,
What's
Kazuya.
up?
not much. Have you guys already started?
No, not yet.
You can get started though. You can kind of just come in when
Yeah.
you. Oh, here we go.
Hi, guys. Hey guys, I'm Jack. I'm the TA for this class.
How's it going?
Good, good. Just visiting you guys from my apartment in Rexburg.
Awesome.
Sweet, man. I'm in Richmond too. Hopefully it doesn't snow.
Okay. Okay, so does anyone have any questions before we start the
No.
No, I think we're good.
Yeah.
Good.
Alrighty. Okay, I can just start off reading question 3.
Okay.
In previous lessons, we assumed the population standard deviation omega was known. In this lesson, we are making a different assumption about what has changed.
I think that's the first one.
Yeah.
I was reading somewhere where it said it was unknown.
That's what I put down as well.
Me too.
Yeah, that's what it says on the reading.
Yeah, I think it's like the first. Yeah, it's like the first paragraph that says that. Sounds good.
So question 4, it says,
Okay.
is O known?
Um,
Well, look at the thing. It says let the alternative hypothesis be H equals A. Assume that the body is not known.
yeah, it's no, isn't it?
Yeah.
Well, because we have the sample standard deviation, but not the population
Yeah,
standard.
because we can find the sample means on that.
Yeah.
We can't find. Okay.
So are we on question 5?
Yep.
Yeah. So what is the value of t?
So I found the formulation for t, and
Mhm.
to find t, you do x minus u divided s divided by the square root of n. And I got 1.5 out of all that.
Yeah, let me just do it real quick.
That's what I got as well. So when you guys get that, we can confer.
So yeah, it's x minus. Sorry, I had the formula. X
Yeah.
minus right divided by s divided by the square root of n. Yeah.
You guys understand where we got that from?
Yeah. Sorry, can't hear you.
What did you say?
I said, do you guys know where we got that formula from?
On the online textbook that we have.
So yeah,
Yeah.
the formula is the
So-
t distribution.
Right. So it's actually just a different version of the formula we've been using before for z-score.
So is t basically the same thing as the z-score?
Basically, it's just different for. It's just a different distribution. That's all. But it's the same
that's-
idea.
That's just to help with when you don't know the actual standard deviation of the population, right?
Yeah. Exactly.
Gotcha. So did everyone get 1.5 on that?
1.5, right? You said?
Yeah.
That's
Yeah.
Yep.
Just making sure. Okay, I'll go read the next one. Use the following values, which were pulled from the data file body temp for the next 5 questions. Copy and paste them into your software. Use the null hypothesis, HOU equals 98.6. Alternative hypothesis is U is less than 98.6, and the level of significance is 0.05. So yeah, did you guys paste that into Excel?
It's not letting me copy it.
Yeah, so I don't think you can copy and paste it. You just have to enter it in.
Yeah, fun stuff. I don't think it lets you touch any of the quizzes.
You just have to type it in yourself.
What is the X?
I'm about to type all of them really quick, guys. Shoot. And from those numbers, we're supposed to find all these different things. Okay. So for the first one, what is it telling us to find? Because I typed in all of them just barely, or I'm finishing it.
What is X?
It's asking for the sample name.
Yeah.
So
Make
it's
sure-
basically an average.
So make sure you guys know. So it's not X, it's X bar. There's the line above
X
X.
bar.
Yeah, that means X bar.
98.22.
What did you get?
98.22.
98.22. You rounded it to.
Oh, it's 3 decimals. Sorry.
Did the average of all those numbers, or what did you do?
I just average it.
Okay.
Yeah, I got something different.
What did you
Okay.
get?
98.157.
So let's see. Do you have 20 as your N?
What was that?
Is your N 20? Can you hear me?
I can hear you.
Sometimes it cuts out sometimes, sorry. Is your N equal to 20?
Let me just make sure. Probably not.
Like, are there 20 numbers? Your sample size 20?
Oh yeah, let me see. I'll just select all of them to see how many that
Yeah.
is. Oh, I have 21 for some reason. Maybe
I
I
got-
wrote something right.
I got 21 as well.
Oh, wait, maybe I missed one.
Let me
I got
just
the same
read.
number as Key.
Kazi?
Okay, yeah.
No, I got 20. Sorry.
Yeah. I had the same result as you.
Okay.
Yeah, I think I might have typed something twice.
So would 98.22 be our answer then?
I believe so.
Oh, I see what I did. I'll just delete that one. I accidentally put one of them twice. So 98.220, is that what you got?
Yep.
Okay, yeah. I accidentally put them on. Wait.
That's probably like the hardest part about these questions. Typing it in right.
So
Yeah,
are we gonna do 98.22 or 98.220?
I just put, it says 3 decimal places, so I just put 220.
Okay.
Or 3. It says 3.
I think even at the end it'll come out the same thing. Like I think the 0 at the end doesn't really matter. I usually just put it anyways.
Mhm. Just in case that's the way the teacher keyed it in.
What's
What is S? So now we need to find S.
What was this again?
S is the sample standard deviation.
Okay.
Exactly.
So we just do standard deviation of S, right? Standard deviation S on our Excel. Round it to 3 decimal places.
I got 0.922.
Yeah, I got the same thing.
How did you do that again?
So you do standard deviation dot S. It's a function that you have to put
Oh, okay.
on your Excel.
All right.
So once you put that and you just put all those numbers in there, then you should get 0.922.
That's what I got as well.
Mm-hmm. Next is the t-score. It's basically what we did before on the other problem. So we take our x bar.
Oh, okay. 20.
Is that what that's asking us? Is the T?
Yeah, t, or is it t-distribution or t-score is different?
They're related. I mean, they're two different things, but they're related. You get the z-score from the normal distribution, and you get the t-score from the t-distribution.
Okay, so the T distribution is the formula. The T score is the result that we get from it.
Yes.
Gotcha.
So I got negative 1.236. Does that sounds right?
How did you do that?
I just put all the numbers in. The S and T. Oh no, S and X and U.
Is there a way you can plug it into Excel to find the t-score or no?
I made my own formula on Excel.
Yeah, you can do that. Or, I mean, you guys have the quantitative inference procedures spreadsheet, right? Here, let me show you. Do you guys have this one? You should probably have this one, right? Can you see it on the screen?
Yep.
You guys have this spreadsheet? So it's the same thing as the last spreadsheet you made. You used just type in the numbers, n, the mean, the standard deviation, tells you the t-score. This t-score is wrong, by the way, because I don't have the right null hypothesis in there. But it tells you what the t-score is. Do you guys have that?
Yeah, I have that sheet.
Oh.
That's from the last test.
Yeah.
Wait, where is it at?
It was from our last test that we had.
I think you can find it on the data files.
Yeah.
You can find it under data files.
So you just have to make sure on that one you said that you have the right What number was it?
I had the wrong null hypothesis right here. So instead of 10, I should put in, what is it, 98.6. Now my t is right.
Hypothesis for it.
Excuse me?
So we assume that the null hypothesis is true, and we use that number when we plug it into the t distribution.
Yeah.
Okay.
Or else your t is going to be way off your t-score.
Gotcha.
See, if you
So
look at
I got-
the formula is the same thing that Kazuya probably made up. Yeah. Yeah, go ahead.
Yeah, I can't find it. Oh well.
If you want to hang around for a little bit after the meeting, I'll show you where it is.
Okay.
What is it called?
It's called quantitative analysis. Is that what it is?
Yeah, here it says. I'll just show you guys where it is. Let me share a different screen. Okay, so this is my internet. So this is the wiki, right? You go to here, data files,
Oh, okay.
and then Excel tools, I think. Yeah, and here they are. The one that we care about right now is this one in the middle. Quantitative inference procedures.
Okay.
Use this one for like unit 1, I think. And more underneath this one. Okay.
Okay. So for that one, I got, excuse me, negative 1.843. Is that correct?
For number 8, or what?
For question 8.
Okay.
I got negative 1.236. I don't know.
What is our S?
Got negative 0.843.
What did you ask? What was our S, Celeste?
Mm-hmm.
It's sample standard deviation. So that was the answer from one of our other questions, which is 0.922. And then you're supposed to divide that by the square root of 20 because that's our sample size.
Yeah. That's what I got. That wasn't the one I was thinking of. What is the other number that's in there? It's like X bar minus, and then what's that number supposed to be?
Then it's by the population mean, which is the null hypothesis right now, and that's 98.6.
That's the 98. What is that? 98 point.
Yeah, that's given to us by the question.
98.6. 98.6. Okay, so what did you guys get? I
got negative 1.843.
Yeah. That's what I got. Negative.
Oh.
Yeah, negative 1.843.
What did you guys put in as U?
It's
Yeah, that's
98.
the 98.6. That's what I was asking because
Okay. I got the same thing there. 2.
98.22 minus 98.6 divided by 0.922, which is also divided
Oh, okay. Sorry.
and then you have to make sure you do 20, the square root of 20 after that.
Okay. Yeah. I hard coded the formula. That's why I got it wrong. So it's I got negative 1.843.
Yeah.
Uh-huh.
Okay.
So question 9 is asking, what is the p-value?
What was the? Oh, there we go.
So, let me see.
Mm, mm.
I'm trying to get this.
So, okay. So we're looking for smaller.
Okay.
So I got on the Excel thing that Jack just provided us. I got, I don't know, it says 1. Is that right?
I don't think so.
Yeah, that's what I thought. It didn't make sense.
Let's check the question again. Go back to the beginning of the question, like where it gives you all the information.
Mm-hmm.
So where it gives you all the numbers, right? So what is the null hypothesis?
Oh,
No, I thought
okay.
Null hypothesis is 98.6, which is
Yeah,
equal
there's a
to.
few things that you got to put in right. So the null hypothesis is 98.6. And what's the alternative hypothesis?
Okay.
Is less than 98.6.
So
Less than. And what's the alpha?
0.05.
So
okay.
the alpha means, is that, so what is the confidence level then that we're supposed to put in here?
Point.
So in the spreadsheet, what are we supposed to set our confidence level to be?
Oh, I know this one.
I got 0.95 on here.
0.95.
Yeah, it's 0.95. So confidence level plus alpha equals 1. So
Okay, so I got p-value as 0.040.
yeah.
Okay, so
Good
that
job.
makes more sense.
Did you do it after that sheet?
Yeah, I did.
So what formula do they use?
This is really similar to what we did last chapter with normal distribution. So if you wanted to do this by hand, you can. It's not hard either. Here, I'll show you. So, well, do you guys know how to do it by hand? Thomas? Do you go by Thomas or Jordan?
I go by Jordan.
Okay.
But it doesn't matter either way.
Okay. Do you know how to do this by hand, Jordan?
Which part?
How to get the p-value without the spreadsheet?
I don't even remember right now, honestly. So much work
Okay.
going on in my brain.
Let's go through this together. Entire screen. Okay, so we have these things, right? We have like these things. So we know how to get the t-value, right? We're all on the same page on that. So what we had to do is, there on the wiki, there's a distribution applet, just like the normal applet. It's called. Have you guys seen this before?
Yeah.
Yeah. So it's the same thing. So the degrees of, except you had to set the degrees of freedom. So here, what is the degrees of freedom for this question? How many degrees of freedom are we working with here?
Um,
Do you guys know?
looking right now.
We are working with. What was your question again?
How many degrees of freedom are we working with? Let me give you a hint. It's related to how many It's related to the sample size.
You mean
So wouldn't it just be 19?
Yeah.
okay?
Degrees of freedom is always minus 1. So we put in 19 degrees of freedom, and that changes the curve a little bit. And then with that, we'll just do the same thing we did when we had the normal distribution. So you shade the two. So right now we're looking at less than, right? So which one do we shade? Which part do we shade?
The left side.
Yeah, the left side. Okay. And now we put in our t-score. Negative 1.843. Then, and this is this area right here. That's our p-value.
That's our p-value?
Yeah. I think there's some kind of a little bit of rounding error, but it's the same, basically the same value. Oh, no, it's the same. Yeah, 0.0. Yeah, it's the same value. So that's how you do it by hand.
Okay.
With 0.0, what is it, 33?
0.0405. So we were
Okay.
back to 0.04.
Wait, what was that? You guys were cutting out.
That was just the value for the p-value.
Oh, okay.
So the final answer for the p-value for question
9.
9.
Yeah. So it's 0.0405, right?
Yeah, we would just I would just round the 5 off. It's 0.040.
Okay.
Okay. So number 10. What is the correct decision based on this evidence?
So p-value is smaller than, is less than the, what is that, significance level? Is that what it's
Mhm.
called?
So it's failed to reject the null hypothesis, right?
Yep,
That's-
exactly.
No, we reject the null hypothesis because the p-value is less than the significance value.
Yep.
Yeah.
So we reject it. That's correct?
Correct.
Okay. Oh, more numbers to type in.
Following values.
P-value for
Data file.
this.
Use wait time in minutes. Copy and paste them into the SPSS.
These things in.
So with a significance level of 0.01, that makes our confidence level 0.99, right?
0.99.
Yeah.
Yeah.
Want to make sure I got that right. Okay, got it in here.
Okay.
Then confidence level is 0.99. This is 40. It's the not equal to.
Null is equal to, right?
Yeah, and then
Yeah.
alternate is not equal to.
And then the other one is the alternative hypothesis.
Okay. So what are we looking for? What is the
The
p-value?
p-value.
I got 0.995.
That's what I got too.
Me too.
Yeah.
Awesome. Perfect.
And then way up.
What decision
That is correct.
do you make?
So p-value is greater than
0.99.
the significance level,
So
So-
reject the,
the hypothesis, right?
yeah.
You guys said reject the null hypothesis?
Mm-hmm.
Okay.
Yeah, because the p-value is greater than the significance level.
Yeah.
Wait, hold on.
Say what?
Wait, is it is it yeah.
Less than.
Oh,
Are you sure about your answer for question 12?
Mm-hmm.
well, I see what you're saying. Because the level of significance is 0.01, and our p-value is going to be greater. You take it away. The significance level is going to be like it's going to be less than 0.01. Is it? Or it's going to be, yeah, it'll be. Isn't it based off of the level of significance, right?
Yeah. Mm-hmm.
So it's going to be, yeah, so I think, guys, it's going to be failed to reject because if you, with 0.995,
That's
it's
what I'm
going to
saying.
be.
Okay, I think I heard reject. That's why.
Oh. Sorry, it probably cut out. Yeah, I was saying failed to reject because the p-values and the significance level.
Yeah.
Yeah, it cut out when he was talking about it. But, yeah.
Sorry, guy.
We all heard reject.
No, it is failed to reject. That's what I was. Okay.
So there's like a kind of a stupid but handy way of remembering it. You just say when the P is low, you reject a null.
No, when the p is low, you reject them.
When the P is low, you reject a null. What it actually means is if P value is smaller than the alpha, then you reject a null. If P value is bigger or equal to the alpha, then you fail to reject.
Word problem. I hate it.
Yeah. And as you go on in this course, the semantics of it, like the language of it, will get more particular too. So you have to really word it exactly the way the textbook says.
Okay.
Yeah, anyways, you can continue.
So question 13 is just having us use a different hypothesis test of a less than hypothesis.
Yeah, and I already put it in, and it decreases.
Yeah, that's what I found too. So if you use that handy quantitative inference procedures and just change the fact that it's a less than hypothesis test, it takes the p-value down to 0.502.
Yep.
Yeah.
So I got decrease on that. If that makes sense to everybody else.
Yeah, it does.
And then I'll go for it.
No, you can go.
I was just gonna say, I think this makes we make the same decision because it's still the p-value is still larger than our significance level.
Yeah.
Significance level stay the same, so it's still 0.01. So we still fail to reject the hypothesis.
Perfect.
Yep.
Cool. So we just have question 15, 16 left.
Okay.
So 95% confidence interval is 0.05 alpha, right?
Yeah.
Okay.
Okay. So we're just okay. So it's gonna be 23.499.
Huh?
Wait, I don't
How did
know.
you get that, Kazuya?
I don't know. We're still using the same thing, right?
Are we using the same numbers?
We're using the same sample.
Yes, Benny?
Dinosaur.
Dinosaur, it's okay.
このまた
もうちょっとでダイリー終わるから待って。
終わり。
待って。
ねえ、ダイナソー。
ダイナソー見てきて。Thank you.
Your son.
So what I did was change the confidence level to 95%,
Uh-huh.
And then since anything else isn't changed, so the confidence level on the lower right hand corner, it says 23.499.
Yeah.
So we would change that to 23.5 then, since there's just to round to one decimal place.
Yeah.
Oh, no, I think the spreadsheet rounded. Wait. Oh, yeah, you're right. There's only one. Yeah.
So 23.5.
And then the next one is going to be 56.6, right? Oops.
Yeah.
Wrong one.
Yeah.
Okay. I'll go ahead and submit right now.
Okay.
Oh, we got everything.
Awesome.
Awesome. Okay. One more question for you guys. Someone other than Jordan answer this. Explain to me in your own words, what does p-value mean?
You were breaking up. Can you repeat that question?
Tell me what p-value means. Like, what does that number represent?
I don't know. I'm just kind of guessing, but is it a possibility value?
Yeah, it's probability. Yeah, exactly.
Probability.
What probability does it represent?
Probability.
Hypothesis.
You're right. It has to do with the null hypothesis, but that's not the complete answer.
It's to probability of rejecting or not rejecting the null hypothesis, right?
Nope.
Nope. Okay.
We decide whether to reject or not based on that probability. So we get the probability first, then we reject or not reject, not the other way around.
Oh.
Jordan, do you have this? Do you know, Jordan?
Like the answer is as extreme in the above or below situation. Is that what the probability value is?
Yes. Okay. Yeah. So the p-value is, for Jeremy, like you said, it has to do with the null hypothesis. So the p-value means assuming the null hypothesis is true. So for example, for the last question we had, right? We don't know what the population average is. We don't know what the population mean is. Someone told us population mean is 40, and we're not even sure if like this guy is trustworthy or not. So we're gonna say, okay, let's take a sample ourselves, and we take a sample of like 21 numbers, and we calculate the sample mean, which is 40.048. Now we say, if this guy was right, and the population mean really is 40, then how likely was it for us to get? How likely was it to get a sample mean of 40.048? And that p-value kind of answers that question. That p-value tells us chance of us getting that number that's 40.048, or something that's farther away from 40 is like 99%. We're like, oh, okay, so assuming that the population mean is 40, we get a chance of 99%. It's pretty likely. It happens all the time. So that's why we fail to reject the null. We're like, okay, given that null happening, that is pretty likely. If we get a really small p-value, then like a 1% p-value, then we're like, oh, this is really unlikely for this to happen if the null was true. So the null is probably not true. So we probably reject the null. So that's why when the p-value is really low, when the p-value is smaller than alpha, then we reject.
Mm-hmm.
Okay.
No, did you guys get that?
Yeah.
That makes more sense now than from just reading it.
So the p-value is the probability of something less extreme or more extreme than that happening if the null hypothesis is true. Great. You guys have any questions for me or anything like that?
何
I don't have any questions.
もう何ももうすぐ終わるから。
No, I think I'm good.
Me
Yeah.
too.
Sweet.
Thank you for your help, man.
Welcome.
Yeah, thank you so much. Yeah, we appreciate it.
Yeah, me too. You guys have a good day.
You
You guys have a
too.
great night. Bye.
Okay,
All right.
bye, guys.
Bye.